Hello and welcome to another video. In this video we're going to be working on count unguarded cells in the grid. And in this one you're given two integers m and n representing 0 index m and n grid. You are also given two integer array guards and walls, where guards I in walls represents the position of the ith guard and jth wall. A guard can see every cell in the four directions, starting from their position unless obstructed by a wall or another guard. A cell is guarded if there is at least one guard that can see it. Return the number of unoccupied cells. Okay, so essentially every guard can look in all the directions. So here, this guard is going to be able to see these squares, these, and this. But here there's a wall, so guard can't see past the wall. So these cells are occupied, these cells are occupied, these cells are occupied, these and these and these. Okay. Yeah, so this is like the first example, basically, where they tell you where the guards are and where the walls are. Okay. And here, there's a guard surrounded by all walls, so there's nothing. Okay. So I think what we can do, I mean, I'm sure you could do something like DFS or something, but instead, something that sounds pretty easy is we can just make this matrix. Yeah. I mean, we're going to have to use this somehow, or we can either turn this into a set or just make this matrix. So we can build this matrix up like this. So a guard will be some number, a wall will be some number, and then a blank cell will be some number maybe. And basically, we can just iterate in every direction. So we can say, like, let's just start at this row and go left to right. So if we hit a guard, then we can have some kind of boolean as like visible, and we can set it to true. If we hit a wall, we can set it false. And then when we hit a blank cell, we can just mark it. If it's visible, then we'll mark it visible. If not, we'll mark it. We'll just leave it. So basically, what's going to happen here, just to show quickly, is we're going to go left to right. So we're going to say it's visible, it's not visible. So all of these will not be visible. And then we're going to go the other way too. So we're going to go this way and this way for this row. So nothing will be marked here. Then here, this guard will be a guard. So we're going to mark these two as visible and nothing else. Then we're going to go backwards. So we're going to mark this one as visible because the guard will be watching. So all these will get marked. Then here, if we go left to right, so this won't be marked at all. Right here we see a guard, so we'll mark these two. Then we'll go the other way, so we won't mark these. And then finally, for the last one, we won't mark anything. And then we do the same thing up and down, so we do down and then up. So down, we'll mark all of these. Up, we'll mark nothing. Down, we'll mark all of these. Up, we'll mark nothing. Down and up, nothing. Down, we'll mark this one. Up, we'll mark this one. Nothing, nothing. Yeah, so first things first, make a matrix. And for every position of the guards and the walls, we can mark it. So I'll just write some comment like what we're going to mark. So we can say wall is a 1, guard is a 2, and empty. I guess let's make it easier. So empty cell that isn't visited, so not watched, we'll mark it a 1, watched 2, and then guard 3, wall 4, something like that. Okay, so we're going to start off by marking the guards, the walls, and everything not watched. So let's do that first. So let's make a matrix of m by n. So in fact, let's make not watched to make it easier. Let's make it this 0, 1, 2, 3. So then we don't have to mark the walls. This is m by n. All right, now we're going to go through the guards and the walls and mark these in the matrix. So and this will be matrix guard 0, and the other location is guard 1. Yeah. Equals, we'll mark it a guard, so 2. Okay, so that's done. Now we do the same thing in the walls. do this? Yeah. Okay, so wall 0, wall 1, mark the wall 3. All right. Now we're gonna go through each row left to right, and then we'll go through each row right to left. So row equals 0, row is less than m. Yeah. So in this, we're gonna go left to right. So this will be 0 closest. Okay. And then we're gonna, our state will be not watched, so 0 as default. All right. So if the cell is a guard, then we're going to change our state to watched. Else is a wall. Yeah, so it's a wall, so we're going to have our state not watched. Otherwise, if it's already watched, we'll leave it that way. And if it's not watched, we'll mark it as watched. So we can do that should do that. All right, so we're doing this left to right, which is this. Now we have to do it right to left. So same code, reset the state. Yeah, so this is now going to be all right. And now basically we need to do the same exact thing, but for the columns. So we need to go up and down, or we need to go down and then up. So we're going to iterate through the column. State equals 0. This is row. Row is less than m. Same, same, same. Okay, now, so this was going down. Now we need to go up. All right. Hopefully no bugs. Then we need to go through one more time and in any way really. So this way would be fine. So essentially we need to go through one more time and just count the number of unoccupied cells that are not guarded, right? So we're going to go through one more time, have a result. This can definitely be like refactored and stuff, but this is the main thing that we're doing. And basically just say if it's unguarded, then we add to the result. So if matrix row column and not watched in our thing is 0. And return result. Probably going to get some bugs, and it's going to be annoying to debug, so let's find out. All right. Or not. Just kidding, no bugs. Okay, pretty rare. Yeah, I can definitely refactor, like make a helper function, traversing and stuff, but hopefully the idea makes sense. Essentially, whenever a guard hits a wall, they can't see anymore. So instead of like looking through each guard, we can just kind of do like a, I don't know, greedy or whatever it is. Basically, guards can look in 4 directions, so we're just going to look through, and anytime we see a guard, we can say it's from now on it's being watched, and anytime we hit a wall, we can say from now on it's not being watched. That's the idea, and we can do that left to right, right to left, down, and up, and that's basically it. Yeah, so kind of like a BFS, but not really. You can probably write this like a BFS where you put in all the guards, but that actually be kind of tricky. So yeah, because then like if you put in all the guards in traverse, like you can't go from like this guard to like this cell and then start going left and right or something. So You can do a VFS, but it's going to be kind of tricky because you have to write down like what cell you're in and what direction you're traveling. So I think this way is a lot more intuitive. Yeah. And so this is, I mean, basically we're going left to right, which is NM, left to right, NM, down, up, NM. So we're traversing the matrix 4 times, and then we're traversing again to count everything up 5 times, but that's still NM. So, and space, we had to make this new matrix. And I think you have to, because if you have a lot of guards and walls, actually, yeah, you do have to, because like if you don't, if you just maintain like where you're at, how are you gonna look up if the cell's occupied or not quickly? You either need a set, you need to turn these into a set, or you need to make a matrix, which is the same thing. So either way, it's gonna be NM space. And yeah, it's gonna be all for this one. Not too bad. So hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.